A very warm good evening to all of you. Welcome to the and teaching STEM to younger children. And the facilitator for this session is Miss Navpreet Brar. A few words about our facilitator today. Navpreet ma'am is the mentor for Eco Molds Club. Her school deals with sustainable practices through various means during the complete session. She is an artist and proficient in one stroke painting. She loves music, singing, and learning different dance forms. She is a blogger and loves writing about all the elements of life and our daily experiences and learnings. She believes to have a healthy mind, a healthy body is a must. Welcome to Navpreet ma'am. Before I hand over the session to you, ma'am, I would like to inform all the teachers that they will receive participation certificates for the session. So please do fill out the feedback form that will be shared with you towards the end of the session. Over to you, ma'am.
A very good evening to everyone present here today, and thank you, Harsha, for introducing me so well. So today's webinar, I guess, Harsha, we can start. All right. So today's webinar is about introducing and teaching STEM to younger children. Now, it's very important. So all of you, those who have joined me today, all my colleagues and all my friends here, of course, they must be aware about what is STEM all about. But in this session, for the next 45 minutes, we will be talking about that how is it so very much important to introduce STEM to younger children. We talk about the fields of engineering, the field of technology, the field of higher studies and learnings in these fields when children grow up to a certain age and certain level. But does it hold an importance when we talk about younger children? So let's explore together about it in this webinar. Yeah, so here is one anecdote which I want to share with all of you. Few days back in my school, as all the schools are getting new admissions now, so a few days back in my school, I got to meet a child. uh, Obviously he came in for an admission. So his parents said that, ma'am, he's very much interested in science is his favorite subject. So they made him interact with me for some time. So I just asked him that, what do you aspire to become? So he said that, ma'am, I love science and I want to become a scientist. So I just told him that, there's a lot of science happening in our kitchen also. So he was a bit surprised, and he said, science in kitchen. So now my question to all my friends is that, what thing he was missing on? What was actually the child missing on? So I would like to have some responses from all of you on this, and Harsha can help me know what are your different responses. Harsha, are you there? Okay, okay. All right. So my question again is, what was the child missing on? So I was having a casual interaction with the child, and I told him that, you are an aspiring scientist. So, a lot of science happen in our kitchen also. So he was a bit surprised that science in kitchen. So what was he missing on? I just need maybe one or two word. What do you think he was missing on? All right. So, if we are not getting any responses as of now, so the child was actually missing on the observation part. Maybe he missed on observing that what goes in our kitchen every day, right? So all of us know, all the science educators present here must be knowing that there is a lot of chemical processes, chemical or physical changes that we carry out in our kitchen on a daily basis, right? So the child was missing on observation part. Okay, life skill science, there is a response. Life skill science, there is a response. Observation. All right. So, yes. So, you guys are right. So, practical skills. Okay. Good. Yes. So, some of you are replying. So, yes, he was missing on some practical knowledge we talk about. So, usually there is a kind of notion that what we study in science is in the books and in the laboratories, and we miss out on observing what is happening around us. Especially, it is very important to inculcate this habit in children, because now why it is so important, let's see. So what are the characteristics of young minds? So children, all of us know that once they start questioning, so they keep on questioning, but only and only if we give them enough chance to question, right? So children are very curious by nature. And another thing is, another interesting aspect of young minds is that they are very observant, they are very good observers. But again, coming back to the same question, that the child was missing out on something, maybe he was not given a chance, or maybe he was not prompted enough to be curious about things or to observe things a lot, right? So these are the characteristics of young minds, and uh, we all should nurture these characteristics of young minds. So how can we add value to the curiosity of a child? So these are certain aspects which we all as adults can practice, whether we are an educator in a school, in an institute, or we are at home. So how to add value to the curiosity of a child? By giving them opportunity to observe. So it's very important. Observation is the first step that leads to the rest of the process, which we call as scientific process or scientific method, right? So give by giving them opportunity to question. Another important thing is, we should not snub children for asking questions. Let them question, let them clarify whatever doubts they have in their mind, by creating learning experiences for them. Even if you don't want to enter, you don't want them to enter into a real life situation, help them simulate certain things, and then create that kind of learning experience for them, that if in case you are at this particular position or you are in this particular scenario, what will you do then? It's again very interesting aspect is by asking them what if. So what if questions are very interesting, like what if this is right, what if this is not right, what if today it rains a lot, what if on a sunny day there is a sudden storm happening. So again, it helps enhance the imagination of the child. Also it helps enhance the I would say abstract thinking of the child, though abstract thinking is a later stage phenomena which happens if we talk about psychology. But still, children are very smart. 21st century children are very smart, and they will come up with some or the other answers to the questions that you provide them with. Then by asking them why questions, it's very important that they learn to reason, they learn to give logic behind certain things. So these all these things we have to practice as adults for our children, to add value to the curiosity of the child, or to the curiosity of the children that they have. So it's very important that we give them all these opportunities. Now coming to our core topic, that is what is STEM and why it should be so very much uh, proliferated and so very much taken care of even for the younger children. Yes, may I please know the full form from all my fellow friends here who have joined us today? So STEM is an acronym, right? So you have to give me what does it mean by STEM.
Ma'am, Sandhya G. Rao is telling science, math, English integrated, science, technology, engineering, mathematics.
Okay, okay,
Yeah, yeah. Surabhi Tomor is telling science, technology, mathematics, and engineering.
okay.
Many of them are telling those, ma'am.
Right, right, correct. So it is, yes. So the if we talk about what is the full form of STEM, so it is science, technology, engineering, and mathematics. So in most now we also have STEAM. So what is STEAM? STEAM is, again, we have added one A into it, so it becomes STEAM. So if it is, we are integrating art also as per the NEP 2020, wherein art has been given a lot of emphasis by the government of India, to be inculcated and to be incorporated in all the learning areas. So STEAM is also a very important aspect. So if you are integrating art along with science, technology, engineering, and mathematics, so that becomes STEAM. So that will be science, technology, engineering, art, and mathematics. Now I'll just take you through each and every aspect of STEM, and again we will discuss that how it helps children develop that knack of a scientific inquiry, scientific method, design thinking. So let's go through it one by one. Now, what are the characteristics of STEM? So I'll just take you through with all the different aspects of STEM. So science basically deals with the three things. So the first one is observation, second is investigation, and experimentation. So if we talk about observation, so again, observation is when we are aware of what is happening around, or we help children observe the surroundings. For example, if I'm teaching them anything in science, or if I am even conducting a small activity with them, so first let's give children the opportunity to observe. So when they observe, they will get to some kind of question, they will have some kind of question in their mind. Then if we are giving them opportunity to observe, they may get to know what is the problem of that particular scenario. I'm just taking a generic example here. So observation is the first step that leads to further investigation. Then investigation is, again, so there is a difference between investigation and experimentation. So may I again please ask my fellow colleagues here if anybody know what is the difference between when we talk of investigation and experimentation. Is investigation same as experimentation, or there is a difference between the two?
Mr. Raja is
Mr.
telling different. Ipsita ma'am is also telling different.
Okay,
Monica Garg ma'am is also telling it is different.
okay,
Then Vanita Jaikumar is telling investigation is a kind of research.
all right.
Investigation is collecting the information.
All right, all right. So again, my next question is, thank you so much for telling this. And now my next question is, what is the difference? Maybe if you can tell me in just one line, or you can just write down, what do you think is the main difference between experimentation and investigation?
One of the ma'am says investigation means questions. Experimentation is to use our ideas to see the result.
Okay.
Yeah, experimentation is activities and investigation is to inquiry information.
Right. Right.
Experiment is about trying what is investigated.
Okay. Okay.
Yeah, one more teacher says experiments means practical.
Right, right. Thank you so much, everybody, for actively participating. Investigation again. So let's, yes, both of these terms are different, though sometimes we may get confused and some people may use it, alternatively for each other. But investigation is not the actual scientific way of carrying out something, whereas in experimentation, we strictly follow the scientific method. This is the major difference. Now I'll give you one example for how we can differentiate between both. So when we talk of an experiment, so we also talk of constants and variables, right? So we set up an experiment, and then we, if we are taking care of maybe three quantities, so we keep two of them variable and one is a constant. For example, if I'm conducting an experiment in the laboratory, let's take an example of checking that how sunlight affects the growth of a plant. So herein I have taken water, I have taken the carbon dioxide supply is enough, water is there, right? A potted plant is there, but then what is varying, we will change the conditions for the presence of sunlight. So that is a variable, right? So variables are, so experimentation, when we talk of experimentation, we talk of purely scientific method wherein we set up an experiment, we conduct our experiment based on the values of variables and constants, then we take out a, then we observe, then we write down the results, and then finally we conclude that what is the whole thing about. But when we talk of investigation, in that case we do not go for, and also in experimentation we establish cause and effect relationship. But when we talk of investigation, investigation not need not necessarily take care of the complete scientific method in its proper flow. Now again, another example we can take for investigation is like, investigation can be that what would be the length of, to what length a plant can grow in 1 month. That is an investigation. Now if I want to check what, how the plant growth would be affected when it is grown in different types of soils, so that will be experimentation. So experimentation again deals with quantitative results, we can say. Investigation deals mainly with the qualitative information, right? So science altogether, if I haven't listed all the steps of the scientific method discreetly here, but the main focus when we talk of science aspect of STEM is that is helping children know about what do we mean by observation, what is investigation, and what is experimentation, by helping them conduct little activities through these through in this particular aspect of STEM. So I will be taking you through a few examples also by the end of the session, so that all these things what I'm talking about right now, it will become more clear in that example. Right, so moving on, now we come to the engineering part. Now, engineering part of STEM consists of two main components, that is design thinking approach and tinkering. So you all must have heard about the word tinkering used a lot in many schools, in even in the primary wings, even in the primary years and senior and middle years also. So schools introduce tinkering in their schools, and otherwise for students, sorry, and otherwise tinkering classes can also be called as STEM classes, right? So different schools may have different terminologies for this, but tinkering, what is the literal meaning of tinkering? It means making changes or improvements. Like tinker, especially like for example, a child is playing with a toy car and it gets curious that how it is working. So so the child just opens it up, all the different parts it opens up. He or she opens up and then again trying to fix all the parts. Or if suppose the toy car is not working properly, so the child is trying to make some changes, some improvements into that. So that is tinkering, right? So when we give opportunity to children to tinker, to make changes, to make improvements in certain things, that is also a part of engineering. So basically, we are giving children an opportunity to become an engineer at that particular age, do some engineering with the help of tinkering, with the help of making some changes and some improvements in the given task or models, we can say. So, design thinking approach, it consists of again four main steps, which includes ideation, making models, testing, and redesigning. So, when I talk of ideation, so ideation is again, if I talk about the literal meaning of ideation, an idea. So, if I have given any again any task to the students, and they are supposed, for example, I have just given them any model to make, right? So I, before they come to the model making, I have asked them to design that model. So that is ideation. So they may make a drawing of it, they may draw, I mean, they may make a sketch of it, or they just make a small prototype with the help of paper or scrap paper or the sheets, anything, depending upon what the teacher is asking them to do. Then that is ideation, that is basically only the sketch or a design that a child can make. Then making models, so shifting or converting that design into model, so that is the second step. Now after making model, it is not complete, only making models is not a complete thing, we need to test also. So herein again, by following all these steps, we are actually exposing children to what is done at higher levels when uh, the things are designed, the machines are designed, and how those are done. So at a very young age, though in a very playful manner, they are learning all these different steps, and these steps have to be reinforced by making a proper curriculum, by designing special sessions for them, so that kids are so very much aware of these steps. They may not remember the actual names or terminology which we are using here, but they will definitely remember the steps because they are doing it on their own, right? Under the proper guidance, under the given instructions, children are doing it. So making, so ideation, then we move to model making. Now after the models are being made, then we introduce testing. So they are given certain criteria and they have to test on it. For example, just an example, that in my when we were conducting classes with my kids, when I was conducting classes, so they were given a rainwater rooftop rainwater harvesting system to make. So obviously they were told, they were means we teacher the teachers also made with them when they were in the STEM class, and then they made it, and then they were given a criteria. So what was the testing part? So they were supposed to test it, that what the structure that they have made of rooftop rainwater harvesting system, is it actually working? Is the water flowing down the roof? Is the water flowing through the gutter? Is the water flowing into the storage tank? So whatever design they have made, is it working? So it is very important once children make the models of, it is again a very important aspect of STEM classes, which we usually may miss on when we are conducting normal science classes with them. So a very a very good advantage of STEM classes is that these children, they help in, I'm sorry, these sessions help children actually perform things and know that whatever they have done is correct or not. Then after testing, so if there is some kind of flaw under the given conditions, if their model is not compatible with what is being expected or what instructions are being given, then they are supposed to redesign it. So you see, when we started from ideation to redesigning, so many steps children have covered. So ideation is wherein they are developing an idea. Then they are having some hands-on practice of converting that idea into a model. Then they are again applying their critical thinking, their logical thinking to test. Is it happening? Is it proper? Whatever we are expected to do, whatever model I have made, is it is it okay with the expectations? If it is not, then they're also getting an opportunity to redesign it. So again, coming back to that, so all these things are very interesting for the children. but only if they are conducted in a manner wherein wherein these steps are followed in a sequence, and children get opportunity in a proper way to do these things. So this is about the engineering part of STEM. So like these two examples I have just displayed in the pictures here. So one on the left hand side of the screen that you see is a hoop glider, and on the other side you see a catapult. So again, you can see that assembly is very simple. But if I talk about hoop gliders, so they got to learn in this about what is lift, what is thrust, what is gravity. So these forces they were able to learn about. They got to know these terms, and they even performed the testing by, I mean, help by throwing these hoop gliders to a distance, helping them glide, and then also testing the distance, that checking the distance, that to what distance the hoop gliders are flying. Then this is the again the this one which we made, the catapult, which we help children make. So these again, this is a very technical thing to make, and again children are made to test that if they are making this catapult, so what should be adjusted here. More popsicle sticks should be added, or there should be some other changes to be done. So there were some specific conditions given to the children which they had to follow, and then they had to test their catapult, and they also had to check that to what distance they can the catapult can throw a ball or whatever material they were made to use. So these little activities also engage children very much, and also help them develop these scientific aspects at a very young age. Now coming to what the technology part. So tinkering, engineering and technology. So when we talk of engineering, engineering is a process that leads to technology. So technology, we can say, is the end product, right? So tinkering is, again, we conduct the tinkering sessions with children at a very young age. Then at higher levels, obviously all of you are aware of what are engineering courses and everything, right? And then those processes further leads to technology. So again, so these technologies are further used to design certain new things. Again, the process starts from the scratch. Now coming to the mathematics part. So all of us are aware of, so those who are mathematics teachers here, so they all are very much aware that what we teach in the younger grades. So here we are catering to children from the age group of grade 1 to grade 5 or so, or grade 4 or so. So again, when we talk of mathematics part of STEM, so what does it again, what all kinds of skills are developed in children under this aspect of STEM? So that is logical thinking, computational skills, data handling, data interpretation. Now of course these two terms, that is data handling and data interpretation, seems very big for the children, those who are in grade 1, 2 or 3 and 4. But again, as I was telling you, that how we present the material to the children and how we encourage them to enter into that arena of where we want them to bring out those skills, so that makes a lot of difference. So a very, again, when we design sessions for them, we have to come down to the level of the children to teach them what we are expecting them to do. Again, teaching is a challenge at this age to the students, because you have to deal with very simple terms. We have to bring a very complicated terms to a very simple term, and then uh, deliver it to the children. So these are the different uh, skills that children develop as a part of uh, as a part of mathematics when we talk of STEM. So when we talk of data handling, so what kind of example can we take when we talk of data handling? Can anybody just give me an example, since we are talking of STEM? So STEM is more of practical work that we do in these labs or in these sessions. So can somebody just tell me an example of how we can introduce data handling to children, so we can have a quick discussion? I mean, what you people think, and what I have to tell.
Information regarding scores of a match,
Okay.
classification,
Hmm.
or maybe marks scored in a test,
Okay. Mm-hmm.
record the data, analysis.
Mm-hmm. So data analysis again is a very big term for the children. So how would you help children analyze data? How, what would you do? I mean, just how can we do that? I mean, any other simple way of making them handle data?
Chitra ma'am says interpretation. Then Sanida ma'am says collecting observations, number of
Okay.
days in a month, then temperature in a month,
Okay.
grouping and sorting items, collection of information. Then
Hmm.
Rashmi ma'am says numbers of members in our neighborhood. Sandhya
Hmm.
ma'am says storage of information. Nidhi ma'am
Hmm.
says classification of things. Then Siju says data received from motion sensors. Then collecting ages of classmates to find the average age of the class. Season, grouping items.
Right,
Ga-
right.
yeah.
Thank you. So yeah, yeah. So good response. Yeah, please, you can carry on if there are more.
Chitra ma'am says survey. Then Mr. Sundar says collection of height of a student in a particular class.
Hmm. Hmm. Hmm.
Then Manisha ma'am says different newspaper. Then average rainfall by Pushpa ma'am. Then
Right.
Kumar sir says he says what is the most liking between breakfast and playing different games. Then date
Okay.
of class students. Yeah.
Right. So I guess more of you are mathematic teachers here. Right. A good response for this part. Yeah. Yes. So all of you are more or less correct. Yes. So when we talk of data handling, so yes, any kind of data can be given for children to collect. So maybe a very simple example could be that collect data, the number of students that whose names start from A in your classroom. So or the please write down the number of students who are maybe 4 feet in height in your classroom. So again, so this is data handling. So again, data representation that I have not mentioned here. So again, when we collect data, so it has to be represented also. So representing data is, again, there are different ways of representing data. So what are the different ways of representing data? Once we have collected those figures, once we have the figures with us, or whatever information we want to have, so data handling includes collecting and data representation, right? So what are the different ways of data representation, and what is, then my next question I'll ask next. So what are the different ways of data representation?
Ma'am, they say bar graph, pie
Yeah.
chart, graphs, graphical representation,
Yes,
uh,
yes,
yeah,
yes.
histogram.
Yes, yes, very correct, very correct. So for the children, so what do you think? Like when we talk of young children, so if I introduce them histograms, will they understand? No, it's not that. Sorry, please don't mind that I'm pointing that out. It's just that I'm trying to say that when we are talking about teaching STEM and introducing STEM to the younger children, so it's uh, like simply bars, they will interpret it as, okay, so this is bar graph. So if there is a line drawn, go literally with them, yes, it is a line graph, right? And then the basic thing, there is a I mean x axis and y axis, so we can call it vertical and horizontal. It's just coming down to their level, and then handling them to make them understand what we are trying to deliver to them. So very right, all of you. One, we collect data and then we represent it. So these are the different ways of representing data. So you all are, you all can use any good way. The pie charts are very good for children to handle. Bar graphs they handle very well once they are made to understand that what is it. Line graphs can be very easily handled by them. So in a very simple way. But yes, when if I talk about my age, and when my schooling was happening, I was not very much aware of these things when I was very small. But nowadays kids are, because in the teaching profession also there is a lot of changes are happening, right? So we all are also becoming very much informed when it comes to what we are trying to deliver to our students. So yes, data handling involves data collection and representation. Now, my next question is, what is the difference between data representation and data interpretation? What is the difference between data representation and data interpretation?
Ma'am, they say repetition of data. Interpretation
Repetition.
means reading information from the graph, and representation is making a graph.
Right, very right.
Extracting the findings from collection of data, comparison of data, conclusion. We can
Very
draw results from the presentation, drawing conclusion and getting information. Comprehending data representation is data interpretation. Then good explanation, they say.
Very good, very good. Yeah, very correct, all of you. Yes. So, data representation is the collected data, how we present that data to the audience or for themselves, for ourselves, or in a class maybe. And then data interpretation is opposite, that you are already given, children are already given a bar graph, maybe a pie chart, and they are supposed to uh, gather information from the given thing, and then they are given a task to do, maybe in which they are answering certain questions, or there is a discussion happening, or there is an activity based on the same. Yes. So data interpretation is getting information out of the data that is graphically represented. Very correct. So all these things are taken care of when we talk of the mathematics aspect of STEM with respect to younger children. Okay. Now, why should STEM be introduced from a very young age? So, we have discussed so far what are the different aspects of STEM and what all things they help to develop in children, what all different skills they help they develop in children. Now, further is again technical skills again is a very important aspect of when we talk of STEM education. Then beside technical skills, there are other skills which are, we can club them together as life skills, or we can call them as inter and intrapersonal skills. So one by one again, so what are technical skills that can be developed in children when we deal with them through STEM classes or in the STEM classes? So that is the creativity. Again, you can creativity, if you have given them a chance to design something new from scratch, you have given them some materials and you have given them a task that design something out of those given materials in whatever way you feel like, but you have obviously given them the objective that you have to design. So objective means there has to be a purpose, or whatever the children have to design, there has to be a purpose for that. So that will bring in the creativity of the child. Then critical thinking again. So when we are trying to solve a problem, when they have observed something, now they have been given a question to solve or a problem to solve, so they will develop that method of solving the problem through critical thinking. Then innovative thinking again, if they want to change, so the model that they made didn't work proper, there has to be some kind of changes in that, or they have observed something at home which is not working proper and they want to change that, so they can gain that skill, they can get that skill from these sessions that we conduct with them, and they can apply that kind those skills at the in the real life situation also. So innovative thinking, these STEM classes help children develop innovative thinking. They become innovative in a way they think. They do not just look at what is already made, they start looking beyond it, that this is okay, this we have, but what else can become out of it. So that falls under innovative thinking. Then design thinking again. So when we look at design thinking, so designing something is not only that I have just created a craft ball and I have designed something very good. When we talk with respect to STEM sessions or STEM classes or STEM education, so design thinking encompasses what, why, how, where, all these aspects. That what is it, how it will be utilized, where it will be utilized, and why it should be utilized. So all these aspects are covered under design thinking, and we can uh, I mean promote this kind of thinking among young children through STEM classes, by giving them little tasks, by giving them little projects to make. So again, as I told you before, that they may not reach the level of where the engineers or technicians or technologists are there, but yes, from very little stage, they will, from a very young age, sorry, they will start learning about these steps, that these are the steps that are being followed at a higher level also. And when they will grow up to that level, so already they have inculcated in themselves those skills, they have developed those skills, and then they will be able to polish those skills in the later in their life. Then problem solving, a very very important aspect of STEM education. So STEM education promotes problem solving among young children. Sometimes there is a very simple thing that we miss on daily life में चल रहा है कुछ, daily kids are also observing, but then so we pass, for example, again a very simple example, we pass on by a road, and then there is a lot of plastic polythenes being accumulated around. How many times our children question us, or how many times we make them see that area and stop by and think that what could be the solution to this. Again, I am not saying that every setup is good for this kind of thinking or to promote this kind of these kind of skills, but through STEM we help children develop this skill of problem solving also. Then inter and intrapersonal skills. So inter and intrapersonal skills, again, very important for a person, for a child, because everywhere he or she is not going to get the same kind of environment. The environment will change. So when we have STEM classes with them, so we usually take care that they are sitting in a collaborative arrangement, they are sitting in groups and working together. So that help promotes collaboration, that help children develop communication skills, that help children develop empathy for each other. They help each other. They are they are taught, and those skills are again inculcated in them, wherein they think, they accept others point of views, and they learn to empathize with their fellow mates. Teamwork. So STEM classes also promote teamwork. Then time management, again a very important aspect of one's life, that they have to perform the tasks in a given time. So that also help children condition themselves how to manage their own time. Next, another very important aspect of STEM education is that STEM education also help develop a sustainable mindset. So nowadays, STEM is not only the scientific or technological part that we are taking care of, but also help children empathize with their environment. We also help children empathize with their environment and think that what could be done through the through STEM education for the sustainable development of our planet, our country, our city. So many different things are taken care of. All these SDGs are taken care of, and children are made to work on certain projects based on these SDGs. And again, I would like to say here that a child's mind and heart is very sensitive. So the way you will mold a child, and if we mold the child in a good direction, they will become good citizens and informed citizens. So this is again on our part, that how we are nurturing our children and how we are grooming our children. We should help them become technologically sound, logically sound, and also help them bring in sustainability in their lives. So again, STEM education promotes sustainable education also. Then, last but not the least, I'm just taking you through this example. So, what kind of activities can be conducted? This is just one example, and all my fellow mates here are learned people, and you all can promote these kind of activities in your own institutions for younger children to help them develop all these skills in them. So, an example for the same is, so there's a problem that a lot of pollution occur from the garbage produced during the packaging of street food. So this, I am giving, like, it is just an example, so I give this problem as a challenge to students. So what is the challenge for them? The challenge is they have to design a street food packaging solution that fulfills the following criteria. So there are four criteria given here. The material of the food packaging should be decomposable, the cost of the item should be less than 100 rupees, then it should be healthy and nutritious also, and it should be attractive, so that the means the food item can get a lot of customers. So here, when I talk of this example, and when I talk of STEM here, so what all things are we, what all learning areas are we addressing here? Can we have a quick answer to this? You just have to take an idea from these four criteria that I mentioned here. So what all learning areas are we addressing in this example for children? So we talked about all the different aspects of STEM, right? So what are we addressing in this example? What am I addressing? I mean,
Problem solving, ma'am.
yeah.
Babita ma'am is telling problem solving. Then another teacher is telling learning by simulation. Then how
Okay.
to solve problem, practical knowledge and experience, critical
Hmm.
thinking.
Hmm. Hmm.
Then environment friendly
Hmm.
packages. Then their
Right.
creativity, real life problems.
Yes.
Again, critical thinking, waste management, awareness about
Right.
environment, collaboration,
Right.
environmental
Right.
sustainability. Yeah.
Right, great, thank you. So, first thing is that it is interdisciplinary. So, if I talk about the material of food packaging should be decomposable. So, first point. So, herein again, we talk of the engineering part. So, we have to design a food packaging of the sort which is decomposable, or we have to use, right? Then, if we talk of the cost of the food item, so here I want to test their computational skills, or I want them to use their computational skills, not test, but yes, I want them to use their computational skills, so that they can design a food item wherein they may have to note down the cost of the ingredients that they are using, and how much in grams the food item will be produced, I'm sorry, packaged, and how much quantity of the food item will be. So all these things are again the mathematics part, right? Then food item should be healthy and nutritious. Again, the science part is covered here. The body science is covered here, that it is, I mean, again, also I can point out here that the SDG number, that is, good health and well-being, is covered here, right? So sustainable development goal, which is one of the sustainable development goals. Then the food item and packaging should be attractive. So here comes in the creative thinking of the child, that how they can attract the customers by packaging their food very nicely. So I must just mention here that we had a session based on the same, though it was a interrelated session with other sessions. And I must tell you, children, the little ones, they came up with such beautiful dishes, and they came up with such beautiful packaging wherein there was no waste generated. So I was wondering that in normal life, when we go to a street, I mean, cart, and then we go for eating food, why don't we just, I mean, just what to say? Why don't we just inform those people that this could be done? But then, yes, again, everything comes with a system. But I was very happy to see the response of the children, that they were so very much excited, and they came up with such wonderful solutions to this problem that was introduced to them. So, children, if we give them the opportunity, definitely they will learn a lot, and they will learn in a way which is very good and sustainable. So, my again, I would just like to end with a quote here. So do not give your children answers to remember, instead give them problems to solve, and then you guys will see the magic happening on this earth. So that's all from my side. If anybody is having any questions, Harsha, you can just forward it to me. Thank you.
Many of them are telling very good presentation, ma'am.
Thank
Uh,
you so
how
very much. This is the actual boost which an educator can give an educator further. So these kind of things keep us motivated for doing more sessions like this. Thank you so much. Those are appreciating. I really humbly thank everyone.
one of the teachers is asking, can this be used in technical teaching language as well?
When we talk of teaching language, ma'am, so in teaching language, again, some aspects of it can be promoted through STEM, but exact thing like STEM is more or less uh, for the practical thing. So when we talk of language and literature, so that is more of theoretical, but then yes, language aspects are taken care of when children present, when children are discussing, when children are having a presentation, when they are demonstrating. So yes, the language aspects are taken care of there.
Kartika ma'am is asking, are any resources available for STEM?
Ma'am, you will find a lot of resources online also. If you will go for searching STEM education for primary children, STEM education for or STEM resources for any age group that you would like to, it starts from 5 to 6 years of age to and above. So you can search online. There are many resources. Few and those who are very much active on Facebook or our social media accounts also, you will find many groups wherein you will find the STEM classes, how STEM classes are being conducted abroad also in different countries. So you can even find some nice activities from there. You can take ideas from those activities and you can conduct your sessions based on the same.
Dawa ma'am is asking how to promote STEM in our schools.
Ma'am, one way is that your school is having a proper curriculum for the same. That is one way of doing it. Another way is that these tinkering labs are being established by so many schools. So, there has to be a recommendation from your school authorities for setting up a tinkering lab, which is not same as other science subject labs that we have. It is a different lab wherein children get to know about electronics. The tools are there, so children are making circuits and all, means there is more of hands on. Like suppose they have learned about circuits in their science class, they have done a little activity, but in tinkering class what would be the extension of that? So that is taken care of in the tinkering labs. So your one thing is that your school can have a curriculum for the same, wherein you people can design a curriculum, and based on that curriculum you can have specific sessions designed for the children for different grade levels. Another way is that you have the specific people, those who deal with these tinkering, and you must be knowing about Atal labs also, which is again a government initiative, which is set up in different schools of India. So your school can contact for this kind of setup in your schools. So they send in the professionals from there. Those are not, again, not from the school staff. So you get professionals from there, and those people, they come to your school and they take classes. This is another way.
Ma'am, Mr. Kumar is asking, for from which class do you suggest taking up this STEM class or STEM?
First, grade 1. This my whole session was based only for grade 1 to 4 children.
How to incorporate in social science?
Okay, so STEM learning in social science, ma'am, when we talk of STEM, connection of STEM with sustainable development goals. So, when we are dealing with sustainable development goals, so again, we talked of so many aspects, right? Observation, then investigation and experimentation. So, for example, we take up an example of so when we align STEM with sustainable development goals, all different learning areas are actually covered. So social sciences mein to there is a lot of scope, wherein we talk of zero hunger, no poverty, quality education. We talk of equal opportunities for employment opportunities. So again, children can put into some activities can be designed for children, wherein children are actually conducting a survey. They are collecting data, representing data, interpreting data, and then they are making a report over it. So all these are also aspects of STEM which can be taken care of when we align STEM with sustainable development goals. So in this way, it can be taken up in a very good way for social sciences. And again, geography is again more or less a scientific subject. So geography includes a lot of science. So a beautiful we can design beautiful sessions for the subject of geography, including STEM, I mean taking STEM into consideration.
Ma'am, one more question. Can you suggest some projects which can be done with primary students which comes under STEM? Chitra ma'am is asking this question.
Yes, ma'am, I can definitely suggest you that, but you will have to give me some time. I have already, even Prachi ma'am was asking me yesterday from Center only that if we can share a document with our attendees so that they can have a clear idea. So I'm thinking of sharing few concepts. On those concepts you can build your sessions for your younger ones. So I will be sharing with the team of Center only, so they can share it further with you all if that's okay, if that satisfies your query.
Uh, Thank you, Navpreet ma'am, for a very engaging and informative session for our community of teachers. I'm sure that our teachers have got a lot of takeaways that will help them teach STEM skills in their school to the younger children. Thank you so much, all the participants, for engaging with us today. To register for more such upcoming webinars, please visit my center. Thank you once again.
Thank you, everybody. Thank you for being such a wonderful audience, and thank you, Harsha, for cooperating and assisting me.